liquid starts teams are going to be not into a replenishing the hydrogen tank on the temperatures as it starts warming up. So that means we are now our teams are just going to be replenishing into a liquid starts. Teams are going to be traveling to replenishing the hydrogen tank on the temperatures as it starts warming up. So that means we are now our teams are going to be replenishing into a liquid starts. Teams are going to be traveling to replenishing the hydrogen tank on the temperatures as it starts warming up. So that means we are now our hydrogen tank to a liquid state, and teams are going to operate the liquid hydrogen tank on the temperatures as it starts warming up. So that means we are now operating into a liquid state, and teams are going to operate the liquid hydrogen tank on the temperatures as it starts for the liquid oxygen tank on the starting to load and the super cold propellant onto the rocket, they will first chill down all of the systems and lines. Now, quick recap on how the core stage and the liquid to process go the upper stage. Will first start hydrogen to be in a liquid state. It needs to be negative 400 to load the super cold propellant onto the rocket. The oxygen start down negative 297. So prior to us starting to load, it is very cold onto the rocket. They will first, in order for hydrogen to be in a liquid and see when those 3 degrees super cold temperatures. So that we aren't in order for hydrogen to be in a liquid state, it needs to be negative 423 degrees Fahrenheit. Now, following chill down, we will transition into what is called 297 degrees Fahrenheit to be able to receive those cryogenic temperatures. So that we aren't shocking the hardware, we're not causing any systems to be able to receive those cryogenic temperatures. Of our loading, we will transition into what is called and we're not causing any potential damage unnecessarily. Now, teams actually chill down into we will transition into liquid oxygen and liquid hydrogen tanks on the core stage earlier this morning. A little bit this before. Officially marks the start of our propellant loading. 9 a.m. suggest refers to slowly starting to feed that propellant onto the rocket. Then when we transition into fast fill, this is where we stay for the majority of actually start into slow fill for the liquid oxygen and liquid hydrogen tanks on the core stage. Earlier this morning, loading propellant at a much faster rate. 9 a.m. and that is currently where the liquid oxygen into slow fill for the liquid oxygen and liquid hydrogen tanks on the fast fill for the liquid oxygen tank a little bit before 9 a.m. After fast fill, we transition into topping. To loading propellant at a much faster rate that is needed to this is where we stay for the majority of our tanking loading operations. Why we're topping it off. Similarly to we are following topping, we are now 100% propellant at a much. So now we transition into replenish. And that is currently where the liquid oxygen. This is the last little bit that we're going to be constantly replenishing these liquid oxygen so that we make sure we are again at 100% flight level. Now, after fast fill, we transition into topping. This is the last little bit that is needed to fill the tanks to 100% level. Now you see on your screen there, we can see some venting coming off following the rocket. Topping. This is we are totally now at 100% expected as we begin our loading operations. Some of that liquid propellant starts warming up. It'll start to boil off and vent just means we're going to be constantly replenishing why we see some of that gas. So we make sure we are again at 100% from flight level. Down underneath where the engines are at the bottom, and also a little bit at the top where the upper stage is located. So again, an expected condition. Now you see on your screen there, we can see some venting coming off the rocket. This is totally expected as we begin our loading operations. See some of that liquid the Orion spacecraft starts warming up. stage or that second stage. Underneath there is the Orion stage adapter. The Orion stage adapter is what houses our secondary payloads or the first stage of the rocket. CubeSats. They're shoebox-sized scientific experiments that will go to space following separation from the upper stage and the spacecraft. It's also the smallest section of the SLS rocket. It consists of the propellant tanks, 5 feet. The ducts, the valves, the Orion stage adapter sits the interim cryogenic propulsion stage or that second stage that are down there at the bottom. Next to the core stage, we have our 2 solid rocket boosters, or the first stage of the rocket. Each is taller than the Statue of Liberty. It consists of the propellant tanks, the ducts, the valves, avionics, and it also houses the 4 on those rocket boosters you can see that are down there at the bottom. Now the core stage, the worm consists of the propellant tanks, 2 solid rocket boosters, the valves, avionics, or roughly the length of and it's just taller than the Statue of Liberty. 25 engines that are down there at the bottom. We actually have 5 segments each on each booster. Next to the core stage, we have our 2 solid rocket boosters. Now on those rocket boosters, you can see more than what was used during the space shuttle program. Each is taller than the Statue of Liberty. Now you should also be able to see some black and white markings around the rocket. Now these are used for imagery boosters, you can for see the SLS worm engineering and support team that's based out at NASA's Marshall Space Flight Center in Huntsville, Alabama. They use this for imagery to track and guide the rocket after liftoff and during ascent. We actually have 5 segments each on each booster, and it will also be used in their post-flight analysis. It's actually 1 segment more than what was used during the space shuttle program. Now you should also be able to see some black and white markings around the rocket. Now these are used for imagery for the SLS engineering and support team that's based out at NASA's Marshall Space Flight Center in Huntsville, Alabama. The thermal protection system or that imagery to foam and guide the rocket after liftoff and during ascent. Now this provides the thermal protection for every part of the rocket. And it will also be used in their post-flight analysis. And when the foam is applied, it gives the rocket this light yellow color that the sun's ultraviolet rays eventually tan, giving our SLS rocket its famous butterscotch color. Now the orange color of the core stage is the thermal protection system, or that spray-on foam insulation. Now this provides the thermal protection. To quickly recap, we are in replenish mode for the core stage liquid hydrogen tank. We are about 75% of the way filled on our liquid oxygen tank on the light yellow color that the sun's ultraviolet rays eventually tan. I'll let you know when we transition into topping. Now the orange color of our liquid oxygen tank is the thermal protection system, or that spray-on foam insulation. Teams are also in fast fill for liquid hydrogen. Now this provides the thermal protection for every part of the operations on the upper stage yet. So again, to quickly recap, I'll make sure to report out all of these milestones as they're underway. For the core stage liquid hydrogen tank, it gives the rocket this light yellow color that the sun's ultraviolet rays on our liquid oxygen tank on the core stage, giving our SLS rocket its famous butterscotch color. I'll let you know when we transition into topping for the core stage liquid oxygen tank. And then on the upper stage, teams are also in fast fill for liquid hydrogen. And they have not started to quickly recap, we are in replenish mode on the upper stage for the core stage liquid hydrogen tank. I'll make sure to report out all of these milestones as they're underway. Filled on our liquid oxygen tank on the core stage. But we're still in fast fill. I'll let you know when we transition into topping for the core stage liquid oxygen tank. And then on the upper stage, teams are also in fast fill for liquid hydrogen. And they have not started the liquid oxygen operations on the upper stage yet. I'll make sure to report out all of these milestones as they're underway. This is Artemis Launch Control.
This is
we are
Artemis
currently
Launch
7
Control.
hours
We are
and 30
currently
minutes
7
and
hours
counting
and
from
30
the
minutes
opening
and counting
of today's
from the
launch
opening
window
of
for
topping and in the process of loading.
I'll get more into
cryogenic or
before
those
liquid propellant
onto the
SLS.
Again, we just finished
the liquid hydrogen tank on the upper stage.
on the upper stage.
Now performing
relief test
for the liquid.
This test is basically just
pressurizing
the upper stage
or our
interim
tanks with
relief
capabilities
the relief
of the
capabilities
pressure
to make sure that it can handle that
capability
during
which gets the system ready to receive the super cold
fast-fill and
temperatures.
topping, teams will perform
And then
this test on both the liquid hydrogen and the liquid oxygen tanks on the upper stage.
I'll get more into those, but before
Following
that test completion, we will then transition into topping,
which just means
the liquid hydrogen
loading
on the rest of the tank
until
are now
100%.
performing before they start topping what is called a vented relief
Following
test.
topping,
we enter what is called pressurizing
mode.
the upper stage tanks with heliums to
which basically just means that now we are going to be replenishing these tanks at 100% level, because as we naturally get throughout the countdown, that propellant is going to start warming up and it'll start boiling and venting off, as you can see on your screen there what is happening. So because of that, and because the teams want to make sure that they still have 100% level all four tanks, the two on the upper stage and the core stage or the first stage of the rocket, they continuously replenish the tanks until the final 10 minutes of the launch countdown, or what is known as terminal count. Now, speaking of replenishment, we are currently in replenish mode for the core stage liquid hydrogen tank. So we were just talking about how we finished on the upper stage liquid hydrogen tank. We are also then in replenish mode for the core stage liquid hydrogen tank. On the liquid oxygen side, we are still in fast fill for the core stage liquid oxygen. And then on the upper stage, we haven't started those liquid oxygen operations yet. The teams want to wait until we are a little bit further along in the core stage liquid loading operations before we transition into that upper stage loading operation. Now in total, the SLS and Orion spacecraft are 322 feet tall. At liftoff, SLS produces 8.8 million pounds of thrust. A little bit more than the Saturn V rocket that was used during the Apollo missions, which were roughly 7.5 million pounds of thrust to send those astronauts to the moon. With our SLS rocket, though, you don't just have those liquid fuel tanks that are fueling the rocket, but you also have two solid rocket boosters that are attached on either side. You see there on your screen right there? They also help provide that extra push and that thrust right at liftoff. Now, Let's go up a little bit on the rocket, go back to our upper or our second stage, our interim cryogenic propulsion stage. For those that have been following us along since Artemis I, you might remember that the interim cryogenic propulsion stage for Artemis I provided the big push to send the Orion spacecraft on its way to the moon. For Artemis II, however, it's going to be a little different. And the reason for that is because Artemis II is NASA's first crewed test flight, meaning we are sending astronauts on board this rocket for the first time. And because of that, we are going to have the capability to practice a bunch of different systems and tests and operations that we couldn't do if it were uncrewed. One of these operations is what is called the proximity operation demonstration. This involves the upper stage, or that interim cryogenic propulsion stage, and the Orion spacecraft practicing proximity maneuvers where the Orion spacecraft will practice approaching and getting away from the upper stage in a high Earth orbit. The reason teams want to practice this is in preparation for Artemis III and future Artemis missions for when Orion docks with our lunar landing systems. And so because of this, this means that the interim cryogenic propulsion stage will be separating from Orion much sooner. Meaning that following this demonstration, it will be Orion's European service module that will actually send the spacecraft on its trajectory to the moon. It will perform what is called the translunar injection burn. Now, this proximity operation is scheduled to happen during the first day of flight, so pretty soon. And NASA will be providing you with 24/7 live coverage, starting right now as we have been going through our propellant loading operations, and we will continue throughout the course of the entire mission, including all of the splashdown operations. Artemis II will send NASA astronauts Reid Weisman, Victor Glover, and Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen on a 10-day mission around the moon and back. Orion is scheduled to splash down off the coast of San Diego in the Pacific Ocean. So to quickly recap, teams are in the process of performing a vent and relief test on the liquid hydrogen tank on the upper stage, following finishing their fast fill operations. Again, this test is to just test the tanks that they can handle the pressure that will be happening during this first day of flight. Following this test, we will then transition into our topping phase on the upper stage liquid hydrogen tank, and it'll then transition to replenish. On the core stage, meanwhile, we are still in fast fill for the liquid oxygen tank, and we are in replenish for liquid hydrogen. Now, this is a very, very big and important milestone to me because, again, for those that have been following us along, especially with Artemis II, during our fast fill operations on the core stage liquid hydrogen tank during wet dress rehearsal 1, that was our first test of this Artemis II moon rocket where we tested loading the propellants on board. Teams experienced the liquid hydrogen leaks shortly after getting into fast fill during that first test. They then performed a second wet dress rehearsal where they did not see any major leaks. Tanking loading operations, and it was a very successful test. And so it's great to see that throughout today's countdown for launch, there also weren't any significant issues or leaks reported during our liquid hydrogen loading phase on the core stage. So we are now in replenish mode for liquid hydrogen. We're about 84% of the way on the liquid oxygen tank. And we're also almost there on the upper stage for liquid hydrogen. Now I'll report out once liquid oxygen operations for the upper stage are also underway.
Houston Station, Sophie on 2.
Sophie, the team's with you on 2. Go ahead.
Yeah, I see that it works now, and now I understand what's going on, so all good. I can start my session now.
All right, excellent. Sounds good.